This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I want to show how to find the length of an arc. This is a fairly simple process, like a lot of math, once you understand the theory and the vocabulary. So let's take a look at a typical problem. Find the length of an arc subtended by a central angle of 35 degrees in a circle of radius 6 inches. Let's draw a picture to understand what this is about. So I've got a circle, and we're told that the radius for this circle is 6 inches. So let's draw a radius, mark it as being 6 inches. And we're told there's an angle of 35 degrees. I'll draw that angle in. And it says that this angle subtends an arc. All that means is it cuts off part of the circle, part of the circumference, and that's what we're calling the arc. So that arc, I'm going to label that x. That's what we're looking for, the length of that arc. Now here's how we're going to find it. We'll make a fraction, the length of the arc, x, over the entire circumference of the circle. We know that the general formula for circumference of a circle is 2 pi r, and r is 6. So the circumference of this circle is 2 pi times 6. And now I'm going to set that fraction equal to another fraction. That's going to be the size of the angle, that's 35 degrees, over 360, the number of degrees in the entire circle. And now I'm just going to solve for x. So I'll multiply both sides of this equation by 2 pi 6. And I'll be able to cancel out everything on the left side of the equation except for the x. On the right side of the equation, 35 times 2 pi 6 is going to be 70 pi 6 over 360. And I can clean this fraction up a bit. I can divide both the numerator and the denominator by 10. And I can divide both the numerator and the denominator by 6. So I'm going to have the length of that arc as 7 pi over 6, and the unit we were dealing with was inches. Now, probably what you want to do at this point is take a calculator and enter 7 pi over 6 into the calculator and find out what decimal that's equivalent to. And don't forget to write inches after it. Okay, let's take a look at another one. This time, instead of using degrees, we'll do radians. It's going to be the same general approach. So this problem says, find the length of an arc intercepted. Instead of saying subtended, they're saying intercepted. It'll mean the same thing. Find the length of an arc intercepted by a central angle of 4 radians in a circle of radius 70 centimeters. So once again, we'll draw a little picture. Here's the circle with a radius of 70 centimeters. It says the central angle is 4 radians. Well, that's a little more than half a circle. So I'll draw this central angle, mark it as a 4. And we're looking for the arc here, which is also a little more than half a circle. We'll call that x. So as with the previous problem, we'll set up a fraction, x, the length of the arc, over the circumference of the circle. That would be 2 pi times 70, since the radius is 70. So that's 2 pi 70. And we'll set that equal to the central angle, which is 4, over, instead of 360, I'm dealing with radians, so that's just going to be 2 pi. And now I want to isolate the x on the left side of the fraction, the left side of the equation. So I'll multiply both sides by 2 pi 70. On the left side of the equation, everything cancels except for the x. On the right side, I've got 4 times 2 pi 70, so that's 8 pi 70 over 2 pi. The pi's cancel. I can divide both the numerator and the denominator by 2. I've got 4 times 70. So x is going to equal 280 centimeters. Okay, so for both of these problems, I did exactly the same process. I called the arc length x. I put that over the circumference of the entire circle. And I set that equal to another fraction with the numerator as the central angle and the denominator as either 2 pi or 360, depending on whether I'm dealing with radians or degrees. Okay, so that's basically it. Take care. I'll see you next time.